Hello everyone, in this video we're gonna enable histogram and percentiles for our timer in the last video in order to get in-depth metrics to get a better understanding of our service. For example, you might have heard something like 90% of requests are under 500 milliseconds, but 95% of requests are under 2 seconds. Based on that, there's a big gap between 90% of requests to the rest 10%. Another example can be SLO, service level objective. You might want to set an SLO like 90% requests below 1 second and alert it if it exceeds the threshold. So, in order to do both of these, you need percentiles distributions. Luckily, in addition to the basics of count, total, and max, as we saw in the last video, Timer also contains a set of optional distribution statistics that include histograms, SLOs, pre-computed percentiles, or you could say client-side percentiles. So we can use the distribution statistics to calculate the percentiles distributions. Okay, let's go ahead and check out our code. First, we'd like to see our timer interface. So timers plus, so this one, timer from Micrometers. So as you can see, here's timer extend histogram support. So we know this timer supports distribution statistic. Let's take a look at the hierarchies of the meters. So we have counters, also a kind of meters, and as you can see, counters doesn't extend the histogram support, so that's why counter doesn't support histogram. So we cannot use incoming features in this video to apply to counter. How about long task timer? Long task timer support histogram. So if we have a long task timer matrix, we can apply the same features we are going to do for our timer for long task timer. Gauge doesn't support. Distribution summary supports histogram. Okay, now let's move on and add these statistics to our do sleep methods matrix from the last video. Okay, application of YAML. Okay, to make it easier to observe for us, I will temporarily disable this command text here and this command text here, and the Prometheus endpoint here. Build Cradle. So I'm going to add the Prometheus here. Then application of YAML, and now and opens Prometheus. Notice that we only use this endpoint to observe how the matrix would look like. We're not gonna configure scraping from Prometheus. Hotel Collector did it from the second video. For my case, I'll spin up all the container to avoid printing a lot of log from our service console. But if you don't mind, you don't have to do that. We're not using the infra in this video. Just docker compose -d. Let's start our service. Okay, let's check local metrics. Okay, we don't have do sleep method here, so let's trigger the do sleep local sleep. Okay, then I'm going to refresh this one. So now we have do sleep method time here, and let's check the Prometheus endpoint. Local actuators Prometheus, and I'll find do sleep. Sorry, here, yeah, we have the mask, the do sleep method mask is gauge, and the do sleep method time is type of summary. So this is kind of metric in Prometheus. So in summary, now we have the count and sum. As we know from the last video, count is the total number of requests coming and sum is the total latency of both requests. Okay, let's back to our service. So I'm going to create a file named request.http here. So in this file, I'm going to have a sample request. So for example, I will simulate sending 10 requests. For the first request is sleep in 100 millisecond, 200 millisecond, and the last one is 1 second. In order to simulate like there's some requests coming to our service. And then back to our application.yaml, I'm going to add a distributions percentiles here. So we have under measurements and distribution, matrix, distribution, percentiles. So in the percentiles here, I will paste a matrix. Here's do sleep methods. So this is name of our metric, right? Back to the application. Here's do sleep method timed. Okay, do sleep method time, and I would like to put here so like 0.99. So I would like to see 99% of the request, 95, 90, 70, and 50. Okay, let's restart the service and then send 10 requests from here, and let's track the Prometheus endpoint. Okay, so do sleep. Okay, so now we can see. So we have the quantiles, and this type's now still a summary, right? But we have quantile for 99, 95%, 90%, 70%, and you can see 50% of the request under 115. One thing to remind is you cannot see this text in using the metric endpoint. So here I'll go load the metric endpoint, and I'm going to see do sleep method here. So you will see there's nothing about the quantile text. Let's check with the documentation. So we are in the documentation, actually we are using the percentiles here. So it means public the percentiles values computed in your application. And if you take a look at the micrometers here, so this is a line side percentiles. So the percentiles is calculated from our service itself, the client side. It would be useful, for example, you only have one instance for your service, then you can right away get the percentiles distribution for your matrix in this service. But if you have more than one instance dimension, so you cannot, because these values are non-arrangable. For example, you have two instances. 90% of requests for the first one is 5 seconds, and the second one is 10 seconds. You cannot say that 90% of the request for your service is 7.5 seconds, right? Okay, so that leads us to the second way of calculating percentiles distribution, server-side percentiles. Server here means observability backend. It could be Prometheus, could be Grafana, etc. And in Micrometers, they call it Percentiles histogram. So basically, the observability backend will calculate the percentiles based on the predetermined set of buckets shipped to them. To enable generating these buckets, back to your application, here's application YAML. We are gonna add percentiles histogram enable. So let's do percentile histogram and copy the same here. And this is the boolean. So I would like to enable percentiles histogram for my matrix. Okay, let's restart. Then we're going to send the request again. Okay, and I'm going to refresh the endpoint here. Do sleep. So now you can see we have this bucket because we enable histogram percentiles, right? So let's see how many buckets we have. Okay. So we have 69 buckets redetermined by Micrometers. And you can see here is how bucket works. So this bucket is for any request that less than equal 1 millisecond. Since the faster request is 100 milliseconds, so there's no request under 1 millisecond, right? And if we see this one from 1 millisecond, we're going to have one request, and from 2 millisecond, 200 milliseconds, we're going to have two requests, right? Under 900 milliseconds, so we have 9 requests, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 requests. And you can see any requests are under, both 10 requests are under 1 second. Okay, so we have under 1 second, less than 1 second, we have 10 requests. And we have infinite. So this is equal to the count. So the infinite buckets equal to the count matrix, 10 requests. So if we want to calculate how many percent of the request under, for example, under 500 milliseconds, so then we just take these numbers, divide by 10 the total request, then multiply by 100. Then we're going to have like 50% of the requests are under 536 milliseconds. So now we see a lot of buckets. We may wonder we don't need that many, but over 10% bucket and less than 100 milliseconds are totally useless for our case. So we can configure the upper bound and the lower bound by setting maximum expected value and minimum expected value to get rid of this bucket. So back to our application of YAMLs. So I'm going to add again so this is the lower bound, so it could be 100 milliseconds, and the maximum like to 10 seconds. So if we don't specify any second and millisecond here, so it would be millisecond. And let's restart this one. So what I'm expecting is we get rid of this bucket, and we can get rid of from 10 from 11 here, so we get rid of both of these. Okay, let's restart our service and run our 10 requests. Okay, so I'm going to refresh this one. So now you see the lower bound is now 100 milliseconds, and the upper bound is now 10 seconds. Okay, but now another requirement comes out. You can see all these buckets here are predefined. So how do we define the buckets for our old? Actually, we can do it by configuring SLO. For example, if we set an SLO like 90% of requests are under 300 milliseconds, what we really want here is we want a bucket at 300 milliseconds. So we can get all the number of the requests under 300 milliseconds divided by the total request and compare to 90%. Okay, let's do it. So for example, the SLO, and I'm going to, okay, so we want to 300 millisecond, 500 millisecond, 1 second, and 2 seconds. Okay, let's restart. And okay, run this one. And let's see, I'm going to refresh this one. And now we have these buckets for any request under 300 milliseconds. So this buckets for any request under 500, 1 second and 2 seconds. So we can add the arbitrary bucket that we want here using the SLO. And another thing is we can use update. Okay, sorry, remember here millisecond. I'm going to 1 second, 2 seconds, and this one milliseconds. So we can do like that, right? Okay, let's go into refresh and see the behaviors is still the same. We need to run all of these. Okay, back to our service. I'm going to refresh this one. Okay, so you see the same. The lower bound of the buckets is 100 milliseconds. The upper bound is now still 10 seconds, and we have the SLO here. The bucket for the SLO we defined 300 milliseconds, 500 milliseconds, 1 second, and 2 seconds. Furthermore, one more thing worth mentioning here is Spring Boot offers properties-based filters for configuring SLO, percentiles, and percentiles histogram by name prefix. It means that as long as the name in the YAML file here matches as a prefix of our matrix name, so this matrix will be counted. So you see our matrix is do sleep method time, right? So if we define here only do sleep method, it still match the prefix of our matrix. So our matrix also still be applied. So let's try to do it. So we see that our matrix is applied using this distribution statistic. Okay, so let's do it. So do sleep without method and time. So it should work as well. Okay, then going to stop and restart service, HTTP, and refresh. Here's where's that here. So you see here as our matrix is still applied because the prefix match the name that we defined in the YAML file do slip, right? Okay, I'm going to convert all of these things. And the last but not least, we can use Alt to apply distribution statistic to all the metrics that support histogram, like timers, distributions, summary that we explore from the very beginning of this video. Something like, this one going to change by all, and this one is going to change by all as well. For example, let's restart it, and you can see it's now applied to all our metrics that support histogram. Okay, run the request again, then back to refresh, and you now see this is our HTTP server request, so it's histogram, so that's why they are applied the statistic. Also for our do sleep method, yeah, of course, and HTTP server request active. Yeah, okay, but you have to remember, so this is valid only for percentiles and percentiles histogram. Why? Let's take a look at the Micrometer filter. Micrometer filter class, and if you're going to here, so this is the configuration for our distribution statistic, and you will see only histogram and percentiles here. It support fallback to the old. So for other things like the SLO, sub-level objectives, there's no fallback for all, right? It's the minimum, the maximum as well. There's no fallback for all, so that's why alt cannot be supported for SLO minimum and maximum expected value in the application of YAML here for do sleep method. So if we change this one to all, it won't happen. First, run. So you still see here that there's nothing like, yeah, the upper bounds is not configured, right? It's not valid. The upper bound, the lower bound, and do sleep method, yeah. So only percentiles and percentile histogram supports fallback to the old here. Okay, we'll back to sleep method. Okay, I think I'll end this video here. Hope you can learn something here. So much thank you for watching this video and the series. See you in the next video, and happy coding.